Hi, everyone, and welcome back. It's Kira Garfolo with Greenville Tech's Math 155. Today, we're going to talk about section 2.1, which is coordinates and graphs. So first things first, welcome to Unit 2 for Math 155. This time, we're going to move into a lot of popular concepts with algebra and statistics. We actually get to see some statistics, which you know is kind of my favorite idea. And we're going to start with graphing. So some of this section in particular should be a review, so enjoy that. And then we may get into some things as we go through this chapter that you've not seen before. So hopefully we're building on existing knowledge here. Now, first, let's talk about number lines. Number lines aren't graphing as the way you probably think about graphing, but they are a type of graphing just in one dimension. A number line is just that, right? It's just a straight line. And our consecutive numbers are evenly spaced along that line. Usually we're going to see something like down here below, where it is going to be a horizontal line. You're always going to have 0 somewhere, okay? And then you're also going to have numbers on either side of that, okay? So these over here are positive, and these over here are negative. Now, there are cases that 0 isn't on your number line, right? Like if you're looking at a time period between 1,000 and 2,000, for example, then you might not have the negatives. But generally in this class, we're going to want 0 in the middle, and then your positives to the right and your negatives to the left. Now, if we intersect two number lines, so one horizontal and one vertical, we're going to get what is called a Cartesian plane. Now, that sounds fancy, but really it's the graphing system that you are used to, okay? So we have one number line here, and we have one number line here, and that is the two-dimensional coordinate system that we usually see, the XY coordinates. A lot of times when we see maps, they are going to be Cartesian planes in the real world, and one or both axes may be letters rather than numbers. So in math, we're used to seeing, 1, 2, 3, 4, and 1, 2, 3, 4, etc., right? But you just as easily could have a system like this where maybe this is A, this is B, this is C, and so on, okay? It's really just a way of saying, okay, I want this far on the horizontal and then this far up or down on the vertical. So just like I was saying, our location is going to be stated with the horizontal first and then the vertical. Most often in math, we're seeing the X and the Y, where your horizontal axis here is X and your vertical is going to be your Y, okay? But no matter what you're presented, horizontal first, vertical second. Let's look at some examples here. This is a Cartesian plane. Now notice that it doesn't look like we have much here, right? But this is still all 4. It's just zoomed in on that first, okay? That first quadrant that we're going to discuss here in a few minutes, what a quadrant is. So if we're writing the coordinates for each plotted item, A is right here. So we want to look at our horizontal first, and then we want to look at where it falls vertically. So if we follow here, we see that it's at E horizontally, and vertically it's at 3, okay? So this is going to be point E3. What do you think for B? B, we're at C9. So those are our coordinates, C9, okay? What about this circle right here? We're still at C, but now we're at 11. So we're gonna have C11 as our coordinates. And lastly, the triangle. We see on the horizontal, we're at L, and on the vertical, we're at 6, okay? So we're gonna be at L6. Now that was a Cartesian plane, okay? We had that letter on that horizontal axis. You can have letters on both or symbols or whatever. It's just telling us where to go. But most commonly in math, we have what we call coordinate planes. And in this case, we have 2 sets of number lines, okay? And they're going to intersect at 0, 0, okay? So they should intersect at the 0 point for your horizontal and the 0 point for your vertical. If you've used graphing in any math class, this is exactly what you've used, okay? This is most commonly what you're going to see. Now, it's always wise to label your axes for good practice and so that any reader would know what you're talking about. Let's get some practice here, okay? Remember that they are going to be intersecting here at 0, 0. So this is going to be point 0, 0, okay? If we want to place the letter A on the point 3, 1, now assuming that this is 1, 2, 3, 4, etc. Okay, 1, 2, 3, 4. So each block is a unit. And we're going to point 3, 1. We're going to go over horizontally to 3 and up to 1. So right here is the letter A. Okay. The letter B needs to go on -1, -2. Now remember, these are just number lines. So this one's -1, this one's -2, -3, and so on. And same here, -1, -2, -3, and so on. Okay. So -1, -2 works the same way. We're going to go to -1 on the horizontal and -2 on the vertical. Okay. So this right here is going to be our B right here on that dot. The letter C is going to be on 0, 4. And when we see a 0 first, that means we're not going anywhere horizontally. We're not moving horizontally. We're just going to go straight up to 4. So this is going to be C. And lastly, the letter D on the point 4, 0. 4 horizontally, so we're going to go over here. And 0 for the second number means we're not going up or down. So this point right here is going to be D. Make sure that you guys can do this because these are on a test and they're giveaway points. You guys know how to graph. And if you are struggling with that, certainly reach out for help because you're going to struggle with the rest of the chapter. Now, some of you may recall quadrants, okay? So quadrants are the quad, the 4 pieces that our graph is split into, okay? So this one's quadrant 1, 2, 3, and 4. Now be careful. Notice that they start here in the one we most commonly use, and then they go counterclockwise. So 1, 2, 3, 4. And there's some reasoning here, okay? The reasoning mathematically is because when we measure angles, we're going to measure from this flat amount. So if we are measuring an angle, let's say like this angle right here, we start here at our 0 horizontal, and we're going to measure up this way, okay? So this angle is measured this way. And we'll see some of that in our final unit in this course. But that's why we go that direction. It all goes back to geometry, which goes into trigonometry, which goes into calculus. So everything is kind of interlaced here. So just be careful that 1, 2, 3, 4. Now, some of you may have also noticed or known from a previous class that in quadrant 1, X is positive, Y is positive. In quadrant 2, X is negative, but Y is still positive. Quadrant 3, they're both negative. In quadrant 4, X is positive, Y is negative. You can easily figure that out by finding some test points, but some of you may have remembered that from a previous class. Okay, let's get some more practice here, okay? Using this grid, let's answer these questions. In what quadrant is the point -4, 2 located? Well, you can always plot the point. -4 up 2 is right here. So that is going to be in quadrant 2. You could also note that quadrant 1 is going to be positive, positive. Remember, this is negative, positive, negative, 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 and positive, negative. You can just look at the sign here. Notice that we have a negative, positive. So that is sure enough going to be in quadrant 2. The next one, we have +1, -3. So if we want to look at it, it's +1, -3. It's down here. And so it is going to be in quadrant 4. which again, we have a positive, then a negative, so that lines up with quadrant 4. Similarly, -1 is going to be in quadrant 3. 2, 3 is going to be in quadrant 1. What about 0, 1? 0, 1 is going to be right here. This is between our first two quadrants, okay? This is going to be between 1 and 2. So really, it doesn't belong to any specific quadrant. We can say it doesn't belong to one, it's neither, or you could just say it's between 1 and 2. But notice that it's not actually belonging to any. Similarly, 0.10 is over here, and it is also going to be between. It is actually between 1 and 4. Okay, now let's get some more practice. We're going to plot these points and we're going to state the quadrants, okay? I'm going to kind of move quickly through these, but make sure that you can follow along. Point A is at 1, -3. So let's go ahead and label these real quick. Okay. So 1, -3 is going to be over here. And we are going to name that point A. There's point A. And that is going to be in quadrant 4. Okay. So remember, this is 1, 2, 3, 4. B is -2, -1. So B is right there. It's going to be in 3. 3, 5 is going to be over here. So that's going to be C. Right here. And that's going to be in quadrant 1. 0, -4 is going to be point D. So it's down here. Notice that that is in none. It's between 3 and 4. E is 3, 3. It's going to be right here. That's going to be in quadrant 1. -3, 0 is over here. It's going to be F. Notice that that is none because it's also between. And G is going to be 0.5, 0.5. So we don't have to do whole numbers, right? 0.5 to 0.5 is a half and a half. Okay, so it's going to be right here somewhere. And that's going to be G. That's also in our first quadrant. Now we can talk about going the other way, right? We can say we want to give the coordinates for each point here. Okay. So let's think about giving coordinates. We need to work backwards. We need to see where is it horizontally, and then we need to see where is it vertically. So point A is right here, and we see that this is -1, -2, -3, -4. 1, 2, 3, 4. So we see that that is going to be at -4, 2. So -4, 2. B is right here, and that is going to be 0, 3. C is over here. It's going to be -3, -2. D is over here. So if we label these, we're going to go 4 over and 4 up. So that's going to be 4, 4. E is right here. So we're going to go -2 and up 1. F is over here. We're going to go over 1 and up or down 0. So it's just going to be 1, 0. And G is down here. So we're going to go over 4 and down. This is -4. So we're going to have 4, -4. Now, if we want to graph equations we want to graph all the points for where the equation is true. So we're going to end up with a line, okay? The x coordinate is what we call the input, and the y coordinate is what we call the output. So x happens, we put that value of x in, and it spits out whatever y is. And we can find one variable or the other given what we learned in Unit 1. So for example, if we want to have y equals 5 minus 2x, and we want to find y when x is 2, all we're going to do is say, okay, well, y equals 5 minus 2, and wherever we see x, 2x, we're going to plug that value of x in there. So we're going to get 1, because 5 minus 4 is going to be 1. So our point here would be our x value and the resulting y. So we knew that we put 2 for x, and we ended up with 1. So that's how we would plot that point. So let's think about this equation. For the equation y equals 3x minus 5, find y when x is 3. So here we'll say, okay, well, y equals 3. Now we see an x, so we need to plug in that value of 3 minus 5, which is going to be 9 minus 5, which is going to be 4. We would end up with point 3, 4 here. Okay. Similarly, if we want to have the equation 3x plus 2y equals 12, let's say we want to find y when x is negative 2. This one has an extra step, but we're going to start it just the same way. 3, we see an x, so we want to plug that negative 2 in, plus 2, we don't know why, that's what we're trying to find, equals 12. So now we have negative 6 plus 2y equals 12. And now we're going to solve just like we did in Unit 1. 2y equals, we're going to add 6 to both sides, 18, which is going to give us y equals 9 if we divide by 2 on both sides. So we would end up with the point negative 2, 9. Make sure that you can replicate these. Also, good test and quiz questions. Now, what we did earlier, last slide, is we're finding those points that are on that line. And we say that a certain point satisfies the equation if it's true when we plug the values in, okay? So we plug x in where we see x, we plug the y value in where we see y, and if the equation is true, then we have satisfied the equation. If it's not true, then we did not satisfy it, okay? So for example, let's say that we have the equation 3x plus 2y is 12. We want to know, does the point 2, 3 satisfy the equation? Well, this is our x and this is our y. Let's plug it in. 3 times 2 plus 2 times 3 equals 12. Does it equal 12? Well, 6 plus 6 equals 12. 12 equals 12. So yes, it does. Okay. What about 1, 2? Okay. Well, let's try. 3 times 1 plus 2 times 2. Does that equal 12? Well, 3 plus 4. Does that equal 12? 7 does not equal 12. So no, 1, 2 does not satisfy this, okay? Now, points that satisfy an equation are going to lie on that graph line for the equation, okay? So you can graph a line by basically finding, really only need 2 points to draw a straight line, right? But all of those points, all those infinitely many points are along that line are solutions to our equation. Okay, so now let's look at some practice here. Which of the following coordinate pairs are going to satisfy y equals 3x minus 4? Well, let's plug them in. 0, 4. Remember, this is x, this is y. Does 0, 4 work? Well, 3 times 0 minus 4 is going to be 0 minus 4, which is negative 4, which is our y value. So yes, this one does. Okay. We can circle that one. What about 1, 1? Is 1 equal to 3 times 1 minus 4? Well, we can move over here. Does 1 equal 3 minus 4? Well, 1 is not equal to -1, right? So no. So no, not to this one. Try 2, 2. Let's do 3x minus 4. So 3 times 2 minus 4 is going to be 6 minus 4, which is 2, which is in fact our y. So yes. 4, 8 is going to be 3 times 4 minus 4 is going to give us 12 minus 4, which is 8, which is equal to the y that we had. So yes, that one is 2. And 4/3 0, this one you maybe want to use your calculator unless you're, pretty good at fractions. 3 times 4/3 minus 4 is actually going to be 4 minus 4, which is 0, which is our y. So also, yes, all of these were solutions except for that first one. So if you see this on a test or an assignment or somewhere, remember that there are infinitely many solutions. It's not a matter of just one or just two. Now, let's talk about graphing equations here. The simplest way to graph one is really just to select some x values, use the equation or the formula to find the y values, plot those points, and draw a line through the points, okay? Realistically, you only need 2 points because you're drawing a straight line, okay? Use a straight edge if you're sketching these. This one will be tricky. You can freehand it. When I ask you to sketch, I'm mainly looking for some key features here, but it's a good idea to either use a straight edge or be as careful as you can. You can use more than 2 points to help you stay on that line. I often use 3 or 4. Everything we see in this class will be a straight line. We're not going to deal with quadratics, and we're not going to have curves or parabolas or sine curves or anything like that. So you really only need 2 points, but like I said, you can use more to double check or to help your sketch look better. If it's more convenient, you can actually work backwards. Remember, a solution is a solution. So if it's more convenient to plug y in and find x values, you can. That's not commonly the case in math classes, but sometimes we do see it. Now, when you want to decide what points you choose, sometimes there's some obvious ones that can be helpful. Sometimes you might have some that you always choose. I typically will start at what are called intercepts. In fact, a lot of times I'll only plot the y-intercept and the x-intercept, and I'll call it a day. What do I mean by that? Well, the y-intercept is where that line crosses the y-axis. So that vertical axis, where does it hit on this line? Okay, so where am I hitting along here? We solve this by simply plugging x equals 0 in, because remember, on this line, that's going to be where x is 0. Now you can find the x-intercept, which is where it hits that horizontal line, okay, by letting y equals 0 and solving for x. So now we're working backwards, you can kind of say, because we're not going up or down from that axis. It's just going to be when y equals 0. So let's practice a little bit by finding some x and y intercepts. Now, be careful here. To find the x-intercept, you're talking about letting y equals 0. To find the y-intercept, you're letting x equals 0. It might sound backwards, right? But remember that the x-intercept is going to be when y equals 0, because you're not going up or down. You're staying on that intercept, and then vice versa for y-intercept. So to find the x-intercept, let y equals 0 and solve. Right? So for our x-intercept, we're going to say 5x plus 2 times 0 equals 10. So 5x plus 0 equals 10. That's just going to be 5x. So we're going to end up with x equals 2. For the y-intercept, we're going to let x equals 0. So now we have 5 times 0 plus 2y equals 10. So that's going to be 0. So we know that 2y equals 10. So y is going to be 5. Now this is not a point. This is not 0.25. Okay. This is actually, if we wanted to sketch it, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is a terrible graph. But y equals 5 is right here. So that's our y-intercept. This is where it's hitting this y-axis. And our x-intercept is 2, so it's going to be right here. And as you can see, you only need these 2 points, right? Because we could very carefully, horrible sketch, so you can get an idea of how the line would be. Now let's find the intercepts of the line 3x minus 4y equals 24. Well, find the x one, we're going to let x equals 0, or y equals 0, excuse me. So 3x minus 4 times 0 equals 24. So 3x is going to be 24. So x is going to be 8. And our y-intercept is going to be 3 times 0 minus 4y equals 24. Negative 4y equals 24. So y is going to be negative 6. Now you can think about it. I know I say, okay, when you're finding the x-intercept, you're going to let y equal 0, and that can be confusing. But think about it. You're solving for x, for the x-intercept. So leave x as your variable. When you're solving for the y-intercept, you're solving for y. Okay, so that might help you. These also, if you want to write the coordinates of these, this is going to be 2, 0. And this is going to be 5, 0, 5. Okay, this will be 8, 0, and this will be 0, negative 6, if you wanted to write them in coordinates. If I ask you to find the intercept this or this, it's completely fine. Okay, just make sure you're answering the right question if it's a y or an x or anything like that. Okay, now let's graph something. Let's graph y equals 3x minus 1. Now, again, there's several approaches to this. You could start with your intercepts if you liked. I often find that the simplest approach would just to say, okay, 1, 2, 3, 4, 1, 2, 3, 4. The simplest that I often like to do is just make a table. You can find your intercept. That's fine. It's going to give you the right answer. You'll see. But we can also pretty easily do this. Let's check when x is 0, when x is 1, 2, and negative 1, just to make a point. Again, you only need 2 points, right? When x is 0, we're going to have 3 times 0 minus 1. So y is going to be 3 times 0 minus 1, which is going to give us negative 1. So we're going to have the point 0, negative 1. So 0, negative 1 is right here. Okay. When x is 1, we're going to have 3 times 1 minus 1, which is going to give us 2. Okay. So we're going to have the point 1, 2. Okay. When we have 2, we're going to have 3 times 2 minus 1, which is going to give us 5. So we're going to have the point 2, 5, which is all the way up here. And when we have negative 1, we're going to have 3 times negative 1 minus 1, which is going to be negative 4. So we're going to have the point negative 1, negative 4, which is going to be down here. Now you can see you really only needed 2 of these, but checking more is helpful. And we can connect these very carefully. It's going to be even harder with this electric pen, with a straight line. Okay. And if I ask you to sketch something, that would be good enough. Just clearly mark your points. If I can't draw it, I don't expect you to. I'm not an artist, I'm a math person. Again, ideally in the real world, you'd want to use a straight edge. Okay, let's look at another one. It's a good idea to pause these and work through them. I'm going to do 3 points here. And I am going to do when x is 0, when x is 2, and when x is 4. So when x is 0, we're going to have 1/2 times 0 minus 2, which is going to be -2. So we'll have the point 0, -2. So we'll have this point right here. When we have 2, we're going to have 1/2 times 2 minus 2, which is going to be 1 minus 2, which is -1. So you're going to have 2, -1. Okay. And when you have 4, you're going to have 1/2 times 4 minus 2, which is going to be 2 minus 2, which is going to be 0. So you're going to have 4, 0. Which is right here. And sure enough, all 3 of these points are on a line that we can carefully sketch. Okay, now this one's a little bit trickier. 2x plus 4y equals 12. Personally, you could certainly do a table here. Usually when I see x and y, I don't have that format of y equals something. I'll just do my intercepts, okay? I'll do easiest with intercepts. So let's find our y-intercept first. We're going to let x equal 0. So we're going to say 2 times 0 plus 4y equals 12. That's going to leave us 4y equals 12, which gives us y equals 3. So we're going to have this intercept right here. Okay. And then our x-intercept is going to be, we're going to let y equal 0. So 2x plus 4 times 0 equals 12. So 2x equals 12, which gives us x equals 6. Now we don't really have this here, right? If we kept counting, we'd know that it's over here somewhere. So we could pick another point in the middle, right? Let's say, we could solve for x if we wanted to. There's lots of approaches to this, right? We could say, well, then that means 2x equals 12 minus 4y. So x is going to be, if we divide everything by 2, it's going to give us 6 minus 2y. So if we wanted to plug, let's do y equals 1 for easy math. We know that x equals 6 minus 2 times 1. So that is going to be 4. So we'd have the point 1. We have the point 4, 1. Remember, this is x. So x is 4, y is 1. So here's 4, and here's 1. And now we see that very carefully we could draw our line. Lots and lots of ways to get some of these lines. Show your work. As long as you've used a mathematically sound way, we're good. What if we have the equation y equals 2? Looks simple, right? Well, let's make our table. Y equals 2. Well, let's do it when x is -1. Let's do it when x is 0. And let's do it when x is 1. Easy enough. Well, it doesn't depend on x. Y is always going to be equal to. Okay, I could do x equals 1,750. And guess what? Y is still going to be 2. When y equals 2, we can plot all of these points, right? When you have y equals something, you have a straight horizontal line because you're not going up and you're not going down, okay? Notice here that you have a y-intercept because you're intercepting right here, but you never cross that x, so you don't have an x-intercept. What about x equals -4? Well, we can put any value we want for y, but we're always going to have x equals -4. We know that x is -1, -2, -3, -4. No matter what value I put in for y, x is always going to be, the pen is not calibrated, on this line. okay? That is going to be x equals -4. Now, when we have just an x equals, there's no y involved. Notice that we have an x-intercept. It intercepts right here. But we never hit that y-axis, so we don't ever have a y-intercept. Now, this is another special case. What if we have y equals x? Well, the easiest way to do this is a table. You could do intercepts too. That would be fine. You'd only get one, though, and we'll see that here in a second. Let's say x is -3. Let's do 0, and let's do 3. Well, when x is -3, this tells us that y is also -3. When x is 0, still 0. This is called the identity function. We know that whatever x is, y also is. Okay, so even this little point here or this little point here, it's all going to fall on this perfect straight diagonal line. If you had found intercepts, you'd find that there's only one, right? The y-intercept is the x-intercept because they hit the origin here. Now, there are a lot of applications for graphing, okay? And sometimes, I know it's crazy, but sometimes we're not just doing math for the sake of doing math. I know that's a shock, right? So far in a lot of your math classes, you're like, who cares? We have a lot of applications in this course and a lot of applications for the graphing. Our axes and our points could be something other than a location, okay? We might have the year on that x-axis. We might have the units sold on the x or the y-axis. We might have speed, or we might have miles per gallon. These could be our x's, these could be our y's. We could also have them, you know, kind of all over. You can have any variable in any place, depending what you're looking to show. Something to keep in mind that I alluded to earlier is while our graph typically in math looks like this, it's not uncommon to see a graph in the real world like this, okay? Where you only have that first quadrant. And that's because maybe values over here, down here, and over here are not possible. If you think about month and sales, you certainly hope if your sales are on this axis that you're never going to the negative, right? And your month is always going to go this way. You're not talking about months backwards. You're using just the first quadrant is sometimes pretty simple. Let's consider an application here. A store clerk makes $1,000 plus 10% commission on all revenue every month. So the first thing we want to do is write an equation for the monthly salary using S. So write an equation for S and R for the revenue. We want to draw a graph of this equation with revenue on the horizontal axis and salary on the vertical. So S is here and R is here. Okay. Now we know that that clerk makes a salary of at least $1,000, right? So she makes $1,000 no matter what. But then on top of that, she makes 10% of the revenue. So she's going to make plus 10% of R. But 10% isn't really a good mathematical way to write things, right? If we're talking about writing an equation. So let's write the decimal form of that. Let's say S equals 1,000 plus 0.10 times R. This would be the equation that we want to write. Now to graph this, let's talk about a couple of points here. Again, we only need 2, right? Let's say, okay, well, what if there's no revenue? And then let's say, what if there is, let's think, $10,000 in revenue, okay? So remember that X is our R here and Y is our S here, okay? So if X or R is 0, then we're going to plug 0 in right here and we're going to get just simply 1,000, okay? But if it's 10,000, then we're going to get 1,000 plus 10% of 10,000, okay? 10% of 10,000 is going to be 1,000. So we'll have 1,000 plus 1,000, so she's going to make 2,000 in this case. So we can plot these points. Now we need to be careful let's say that this is 1,000, 2,000, 3,000, and so on. And let's say that our revenue is in, we've done 10,000, so maybe 2,000 by the 2,000s. 10,000s right here. So we have the point 0 to 1,000, so right here. And we have the point 10,000 to 2,000. So 10,000, 2,000. Okay. We can connect these two with a line. That was terrible. But this is what we're looking at. So again, pick 2 points, plot them, connect them. Certainly you can do a better job drawing a straight line than I can on my tablet. Now there's one thing I'm going to go back before we wrap up and mention. When we are talking about an x equal graph, so anytime the graph is x equals some constant, okay, so any number, we have a vertical line. Okay, we'll talk more about this next class. And anytime that we have y equals some constant, you're going to have a horizontal line. Okay, you can keep this in mind, and that'll help you with your intercepts. If you're ever unsure about your intercepts of these, sketch them. See which it actually crosses. Okay. If you have any questions, what are you going to do? Well, you can use your text, practice. Okay. You can talk to the Math Center. You can watch the other videos in our Blackboard shell, use those supplemental materials, and you can ask me. Okay. The next lecture, we're going to talk about 2.2, which is going to talk about the slope of lines. So we're going to kind of go more on what we talked about the second half of this lecture. And then keep in mind that assignment 3 is coming up. Check your course schedule because it's going to be due soon. Thanks for tuning in. I hope you guys have a great day, and I will talk to you next time.